Okay, in this video, I wanted to refresh your memory about subtracting mixed numbers with borrowing. The only time I want you to consider borrowing is if the problem is presented with the denominators of each mixed number already being the same. For instance, if I had the problem 3 and 1/4 minus 1 and 2/4. If you notice, every time you're looking at a problem, I've always told you guys, look at the fractions first. Are the denominators the same? That's the first thing you want to consider before you start to solve a problem that involves mixed numbers, improper fractions, or fractions. Are my denominators the same? In this case, yes. So I don't have to stack them and find common denominators. I don't have to do that. What I have to do here is then look at, okay, my denominators are the same. How about my whole numbers? They look okay? Yes, I can take 1 from 3. I'm safe. Now, pay close attention to your fraction. If I have 1/4, can I take 3/4 away? So if I'm just looking at this fraction and I only have 1 out of 4 here, can I take away this many? Can I take 3/4 from 1/4? No, I cannot. Okay, I cannot take that away. So that constitutes me to have to borrow. So it's very important that you look at the problem closely, and more in particular, those fractions. There's 2 ways you could do this, but for this one, I want to concentrate just on borrowing. So when I borrow, it's just like normal subtraction. I have to get him bigger so that I can then take 2/4 away from him. Well, I'm going to have to go to the 3. So if I take 1 away from the 3, and I'm going to give it to my fraction, he will now become 2. Just like normal borrowing with subtraction. You take away 1, you're going to take 1 away. Now, I want to give him 1, but he cannot look like a whole number. He has to be represented as 1 as a fraction, which would look like that, 4/4. And if I add those 2 back together, being though that is 1, that's actually 1, 4 out of 4 is 1 whole, I would get my 3. So 2 plus 4/4 is 3. But I can't just give him a whole number 1. He has to look like this because I'm going to give it to him so that I can add it to him. So 3 and 1/4 through borrowing, and I take 1 from 3, I'm going to have 2 and 5/4. So that 4/4 is 1 that came from the 3, adding it to him. Now he's 2 and 5/4. Then what I'm going to do is bring down the rest of my problem. Minus 1 and 2/4. Now, my denominators are the same. My whole numbers look to be fine. Now pay attention to my fractions. Can I take 2/4 away from 5/4? Absolutely. Now I can. Remember this too. When you borrow, you better have an improper fraction right here, because you've already had 1/4, and if you're giving him a whole, he's going to be greater than 1 now. So he's 5/4, which is an improper fraction. So I'm going to carry out my subtraction. 2 minus 1 is 1. I won't know what happened. 2 minus 1 is 1. 5/4 minus 2/4 is 3/4, and that is my answer. Okay, so it's just like normal borrowing. The only difference is, in order for me to give 1 to the fraction, that 1 has to look like a fraction. And it's 4/4 because that's the denominator that I started with. And if you remember, I can't add fractions unless the denominators are the same. So he's going to dictate what he looks like. If this was 1/5, it'd be giving him 5/5 so that I can add them together. but in this case, it's 1/4, so he has to look like 4/4. So I hope that helped for that, for borrowing. Another strategy that you can use is you can convert each one of those into improper fractions. So first, let's keep the original problem, or let me give you a different one. That's it. If we go 3 1/4 minus 1 2/4, okay? Same problem. Whole numbers look to be okay. My denominators are the same. I don't have to do any work there. My denominators are already the same. Look at my fractions. Can I take 2/4 from 1/4? No, don't have enough. This is your second option outside of borrowing. If you choose to do this, it's your choice. You could convert each mixed number into an improper fraction. So 3 times 4 is 12, plus the 1, this would be 13/4. Okay? Convert him. 4 times 1 is 4, plus 2 would be 6/4. So now that they're both converted to improper fractions, I can carry out this subtraction problem. 13/4 minus 6/4 is 7/4. Now, if you notice, my 7/4 answer is an improper fraction. Well, the problem was presented to me as mixed numbers. So I have to convert him back to a mixed number. And if you remember, I do that through division. It would be 7 divided by 4. Well, I know if I have 7 marbles, I can make one group of 4. And when I make that group, I take 4 away and I have 3 left. And I also know that when I do this, that my mixed number would be one whole group with 3 left over out of 4. So 7/4 as a mixed number is 1 3/4. And that is my answer. And that's the answer we got. Well, I did a different problem, but this way is fine if you don't want to borrow. I don't mind you guys doing it this way at all. Just remember, if you end up with an improper fraction, you need to convert him to a mixed number. Some of you guys like to do it this way. Some of you like to borrow. I don't care. That's totally up to you. I just wanted to refresh your memory on borrowing and also refresh your memory on this. But you do need to remember, most times you're not going to be able to give an answer as an improper fraction. So if you're baking a cake, you would not say put 7/4 of a cup in. You would say put 1 3/4 cup of flour, not 7/4. So we want to convert these into logical problems and answers. I hope that helps.